Hello students, welcome to the next lecture on the IIT JAM and the GATE mathematics. Today I will describe the differential equation. Myself Dr. Harish. You can simply follow my YouTube channel where you can find the two different playlists. One is for the IIT JAM students and the second is for the GATE as well as CSR NET examinations. You can see there are the various PY question series of the GATE as well as the CSR NET topics. You can watch it and learn many shortcut tricks for these PY question series. So what is the objective is, as I told you, I will cover all those questions related to the differential equations and the integrating factor. I choose all those years examination paper mentioned at here. So before I start with the PY question series, let me quickly recall you what is the shortcut tricks and the various steps for solving the exact differential equation. First of all, make sure whenever we are talking about the exact differential equation, we always discuss about the first order and the first degree differential equation. That means we can say dy over dx must be fxy, and this must be either it is a linear or a non-linear, that is no problem, but dy over dx power should be 1 and derivative should be single. So any of the differential equation is said to be the exact when this condition satisfied. So if you prove that m and n this condition satisfied, then you can say differential equation is the exact. Make sure m and n are my continuous function. If you prove that this differential equation is my exact, then you can find the solution by using this equation. A very simple approach, you may or know about that. However, what will happen if this condition is not satisfied? Then you called as integrating factor. When the differential equation is not exact, when this condition is not satisfied, because this is my necessary and the sufficient condition. So what will happen, how you can make this differential equation to the exact? I can multiply this by some function, say f of xy, so that the new equation becomes my exact. If this will happen, then that function is called as integrating factor. We have to multiply by some function f so that the given differential equation is my exact. Then you can say f of x comma y is my integrating factor. How you can find the integrating factor? That's a simple tips I will give you. Now remember, my differential equation is my here. Fine. So if I given that m and n both are my homogeneous function. What is the meaning of the homogeneous? That means the degree of m and the degree of the n are my same. Fine. Like x square y square plus 1 into dx plus x square plus y square of dy is 0. So clearly says the degree of this is my 2, degree of this is my 2. Fine. Or I can say this is a y square. No, sorry, it's a y4. So if I consider this is y4, this is y square. Now you can see the degree both are my same. Once you prove that there is a homogeneous function, then you can write the integrating factor directly as 1 over mx plus ny. This is a very important tips for you. If mx plus ny is a 0, then 1 over xy is my integrating factor. On the other hand, if my function are my not homogeneous, that means it must be of the other kind. Then if my function is particularly of this nature, then my integrating factor is 1 over mx minus ny. For example, here you can see this is a product of the xy. This is the f of this. Fine. Everywhere where is xy is written, it must be in the form of the product and the same power. Like if I say x cube y square minus 1 into dx plus x 2 minus 4 xy of dy. So you can see xy is present and both are degree same. In this case it's not the same, then this is not of this nature. Fine. Similarly, if I written here is say my y, so again only the y is present, it is not in the form of the xy, again it is not in this nature. So once you identify that it is of this form, then the integrating factor is 1 over mx minus ny. Another case, if the function is not homogeneous and not of this nature, then you can always start from here. You can subtract them. Either you can use this term or you can start from, you can take x, n is my firstly, n with respect to x and m with respect to y. Now I will tell you very important tips, very important point for you related to this. You have to divide it by something. That something should be the term which is written after the minus here. In this case it is written m, so you have to divide it by m. So if the result, now I have written here is m, so what is the term is x, then it must be the function of the x. If I divide it by m, m is related with the y, then it must be the function of the y. If this happens, then you can find the integrating factor of the first term is e raised to power of this quantity. Similarly for this case is e raised to power of this quantity. Make sure I am again tell you, you have to divide it by those things which is written after the negative. Fine. The last two terms you all know what is the linear differential equation. Make sure the coefficient should be 1, and you all know what is the integrating factor of this is e raised to power px into dx. However, for the Bernoulli case, what you can do, you have to divide it both sides by firstly y raised to power n, then it is my here, then you always consider 1 minus y is z, and then say there is no need of this. You can find the integrating factor directly by using my this tips. 1 minus n, n is my degree of here. So based on these 4 or 5 tips, I can solve each question in a very simple manner. So let's start with the PY question. Before that, you may join my WhatsApp group where we can discuss more questions. If you are the student of the IIT JAM Mathematics and the statistics, you can join through this WhatsApp group. Otherwise, if you are the GATE and the CSR Net student, you can join through this WhatsApp group. So let's start with this first question. So this is my m, because m dx plus n dy. It is given to be exact. That means I have to find these two values. Fine. So what is the partial derivative of m with respect to y? So it's a bx plus 2y. What is the n with respect to x? Is a 4x plus cy. So both are same. What does it means? B is equal to 4, C is equal to 2. So you can see how many seconds you are needed to solve this problem. A fraction of second. Now they are talking about the integrating factor. I will tell you the two different approach. Firstly, I can write this equation in terms of, this is my dy minus 2xy square plus y of dx is 0. Fine. So first method, I can use some formulas. What is the m is? Minus 2xy square plus y. N is my x minus here. Fine. So what is the partial derivative of m with respect to y? Minus 4xy minus 1. What is the partial derivative of n with respect to x is 1. Fine. Now clearly say they are not equal, so I have to subtract them. So if I start from here, for example, then it will be minus 4xy minus 2. If I written minus of n, so I have to divide by n. Is it possible? If I divide it by n, then the function should be x. If I divide it by here, it is not cancel out. It means I have to divide it by m. So what I can do is, if I divide it by m, then I have to return m in the below side. So what is that? It's a 2 minus plus 4xy. M is my here. I can take y as a common. It's a 2xy plus 1. So I can say it's a minus 2 over 1. Fine. Because now I have divided by m. So what is the integrating factor? Integrating factor is e raised to power minus integration of this 2 over y dy. So what is the answer of this? Is 2 log of y. So that means 1 over y square is my right answer of this problem. This is the first method. Fine. The second method, you can see what is the definition of the integrating factor. Firstly, you can choose this my a. Then I can multiply this differential equation by 1 over y. Then your m will be, I can open this bracket, minus 2xy minus 1 over y. And your n will be if I multiply this equation by 1 over y, first option, it is my x over y minus 2y square. Now check whether this is my exact or not. M with respect to y minus 2x plus 1 over y square. N with respect to x 1 over y, both are not equal, so this option is cancelled out. Look about the second option. If I multiply this term by 1 over y square, so this is my m, fine. If I multiply this by 1 over y square, it's a minus 2x minus 1 over y. What is my n? N is my x over y square minus 2 into y. What is the partial derivative of m with respect to y? 1 over y square. What is the partial derivative of n with respect to x? It's a 1 over y square. Both are same, that's a correct option. If I look about the C option, because there is only one correct option, so we got that. And it will take hardly a 10 second. Look about this. If I multiply this equation by y, it is my 2xy cube minus y square. If I multiply this is xy minus, so clearly says m with respect to y minus 6xy square minus 2y, while partial derivative of this is my y, which are not same. Similarly, you can verify it. If I multiply this by y square, then it will be my 2xy raised to power 4 minus y cube, and n will be my xy square minus 2 raised to power 5. So clearly say if I take the y, it will be cube, but it will not be any of these cube appears, so that will be cancelled. Fine. So the only right option is my B is my right answer. For what value of the n the given equation is my exact? This is my m, this is my n. So what is the partial derivative of m with respect to y? So it is my 6xy plus n square x square. What is the partial derivative of n with respect to x? 3nx square plus 6xy. So what is the meaning of that? When they are equal, if they are same, it means 3n is equal to n square. That means the non-zero value, so n will be non-zero, is my n is my 3, because from here you got n is my 0 and 3, but 0 will not be possible, so 3 is my right answer of this problem. The integrating factor of this, so you can see this is my m, this is my n. So if I firstly take this option x square, if I multiply this by x square, then it will be my x square y plus 1 over 3 x square y cube plus x raised to power 4 over 2. Then n will be, if I multiply by x square, it's a x cube, it's a x square y square over 4. Then what is the partial derivative of m with respect to y? It's x square plus x square y square. What is the partial derivative of n with respect to x is 3 over 4 is there, 3x square plus 2xy square, which is not equal, so this option is cancelled out. I can check about the x cube, because this is m, I have to take partial derivative with respect to y, so there is no significance of this, so that means it will be 1 plus y square. What is the partial derivative of n with respect to x? When I multiply this by x cube, then this term will be my x4, this is my x4 y square, so it is my 4x cube y square. So 4 will be cancelled out, x cube will be common, 1 plus y square, both are my same, is the right answer. This is the first method. Fine. If I take the option and multiply them. Other method is again as usual. If I start from here, partial m with respect to y, it's a 1 plus y square, n with respect to x is my 1 plus y square over 4. So if I subtract, because I can say I have to use the n in the denominator, so it means I can use n as a here. Fine. So what is that? If I subtract them, it is 3 over 4 this divided by n, so x is a common, the remaining part is here, so you can see it's a 3 over x, and you can see I have divided by n, it must be of the x form, so which is my fx. So what is the integrating factor? 3 over x dx. What is that? It's a 3 log x. So 3 log x I can written as log of x cube, that is a x cube is my right answer. Okay, if x k power k and this is my integrating factor, so okay, fine. So if I multiply this by x raised to power h and y raised to power k, so what will happen? Because I have to use m with respect to y, so x is a constant, so I can take x raised to power h is outside, y raised to power k plus 1, so y is 1 plus k plus x y of 2 plus k, fine. And what is my n? If I multiply this by here, I have to find the partial derivative with respect to x. I can take y as a constant outside, so x raised to power 1 plus h minus x raised to power 2 plus h into y, fine. What is the partial derivative of m with respect to y? So x raised to power h is outside, 1 plus k y raised to power k, 2 plus k x y of 1 plus k, n with respect to x, 1 plus h x raised to power h, 2 plus h x raised to power 1 plus h of y. Now when both are equal, when you can see when the coefficients are equal, that means 1 plus h is 1 plus k and this is a 1 plus k and this is again same, so it means 2 plus k is 2 plus h, sorry, it's a plus sign, so 2 plus h is minus of this, fine. So what is that? From this case it is h is equal to k, so this option is cancelled, this option cancel. Now from this case it is 4 plus k minus h is equal to 0. You can see which option is satisfied. So this is 4 plus h, so you can see this option is not satisfied because 4 minus 1 is not 0. This option is cancelled. A is my right answer of this problem. Look at this another one. Consider the differential equation here. If f is my this, f is an integrating factor. Very simple. I can multiply this by here. What will happen? It is y. If I multiply this, so what will be my m? M will be my 1 over x square y minus 1 over x square, and n will be my x will be cancelled out, so 1 over x y square. So check whether this is the integrating factor or not. If I partial derivative of m is a minus 1 over x square y square is a 0, n with respect to x is a minus 1 over x square y square, both are same, yes, so it means this is an integrating factor, this is cancelled, fine. Now once this is an integrating factor, what is the meaning of that? How you can find the solution? Integration of the m dx, keeping y as a constant, and the term in the n which is not x, but there is no term which involved in the x, fine. So what is the this is my m. What is the integration of this? 1 over y is my outside. What is the integration of this? Is minus 1 over x. What is the integration of this? Is minus 1 over x, which is equal to c. So it is minus 1 over xy, fine, plus 1 over x is equal to c. So I can take xy is my LCM. This is my c x y. So what is that? Y is equal to 1 plus c x y is my right answer. Now you can see y, these are all y is equal to 1 minus kxy, so I can take c is equal to minus k, fine. So this is a solution, but he said not a solution, this option is cancelled. F is an integrating factor and minus 1, but we always get as a plus 1, so this is not a journal solution, but he said journal solution. This is not a journal solution, that's a correct option. So the right answer is my C is my correct answer. Okay, that's a very interesting question. If this is given to be here as a journal solution of the exact differential equation, this is already given as a exact. What is the solution of this? M into dx, keeping y as a constant, plus terms in the n without x, there is no term is here. So what is the meaning of that? M is unknown to us. What is that? Because this is my solution, so I can substitute the value of c as here plus x y square. Fine. Now how you can integrate them, how you can remove this? I can differentiate with respect to x. So what is that? This is the m of xy. This is my 2x, keeping y as a constant. So this y square as a constant. So 2x plus y square, this is the value of the m. Now your target is to find the value of 1 comma 1. So 2 plus 1, 3 is my right answer. You can see how many seconds you are needed to write these 3 lines. Hardly a 10 to 5 seconds. Okay, now look at these few questions from the GATE 2006. We will cover apart from this 2021 after this GATE examination papers. That is after the 3 or 4 questions. The integrating factor of this. Again, a very simple. This is m, this is n. It means this is not an exact. How you can think about to solve this problem? So firstly you can find my. What is my is? Minus cos y sine 2x n x. Whenever you think about m dx plus n dy, always start from here. You will get a very less time. What is that? It's a 2 cos x. Cos will be the minus sign, so minus minus plus sign. So I can return this is my sine 2x, which are not same. So it means either you can start from here or you can start from here. So if I start from this, I divide it by n, answer must be in the form of the x. If I subtract them, what will happen? It is a minus cos y plus 1 of sine 2x. Fine. So is it possible if I divided this by n, n is my here. Fine. The answer is minus cos y plus 1. But we need an answer in terms of x, so it is not possible. So it means I have to divide it by here. So what is that? If I divide them, it will be 1 plus cos y of sine 2x divided by m cos y sine of 2x. So it will be secant y plus 1. 90% student will think about that. Now this is the function of the y only. So the integrating factor is my here. But remember that we have divided by n. It must be in the form of the x. So what is the integrating factor? E of integration of this part. It's a 1 over cos. It's a 1 over cos is there. So what is the integration of secant is? Ln of secant x plus secant y plus tan y. Fine. Then what will be happening of this? Plus of x. Fine. This is a function. This is the function of the y. So it must be y. I will check it. Where is my? It's a 1 plus cos sine 2x will be cancelled out. So this will be. It will be my y. Partial derivative of m is my sine y. Fine. So it is my sine y. Again this option is cancelled. It's a sine y. So it's a secant and it's my tan y. Fine. So what is the integration of the tan y? It's written in the form of the secant y. So what is the answer of this? Secant y plus tan y. Log m plus log n is log mn. So what is the right answer of this? If you open them, secant square y plus secant x. So A is my right answer of this problem. Okay, which of the following is my here? So again, I can return this equation in dy over dx. So I can return here. Fine. I can convert into the m dx minus n dy. Fine. Now the integrating factor clearly says that m and n are my homogeneous. Fine. So once they are homogeneous, what is the integrating factor? Mx plus ny. So what is that? M is my y, so it's a xy minus xy. This is 0. So whenever mx plus ny, what I told you, mx plus ny is 0. What is the integrating factor? 1 over xy is the integrating factor. So yes, this is my integrating factor, but they are talking about the not. Fine. Now how you can check about the others? Again, a very simple. I pick about the x square, I can multiply this by x square. So your m will be y over x square, n will be minus 1 over x. What is the partial derivative of m with respect to a? This is 1 over n square. N with respect to x will be minus minus plus. Both are same. So yes, this is also the integrating factor. I can pick about here from this. Then your m will be 1 over y. N will be minus x over y square. What is the partial derivative of m with respect to y? Minus 1 over y square. Partial derivative of x is, so again both are same. Yes, this is also the integrating factor. So this is the only one which is not the integrating factor. How? You can see, if I multiply this, it's a y over x plus y, and n will be minus x over x plus y. So if you find partial derivative of m with respect to y, and both are not same. Anyhow, we already discard the three options, so left one is the fourth is the right answer. The differential equation is my exact. So this is the dx, so this is my m, this is my n. What is the partial derivative of m with respect to y? So it's a minus b, sorry, with respect to y, it's a plus b of cos x. N with respect to x, so this is my x, it's my 2 cos x. So what is the meaning of that? B should be 2. So b is equal to 5 cancel, b4 cancel, this cancel, only the left option is my pending. A is my right answer of this problem. Which of the following is not an integrating factor? So you can see, I can write in terms of m dx. So y dx minus x dy is equal to 0. So clearly says, again, they are my homogeneous because m and n are my homogeneous. So integrating factor will be 1 over mx plus ny. But what is the value of the mx plus ny? xy minus xy is a 0. So once it's a 0, so 1 over xy is the integrating factor. Now look about this. If I consider 1 over x square, so what will happen of the m is my y over x square. N will be my minus 1 over x. What is the partial derivative of m with respect to y? 1 over x square. Partial derivative of n with respect to x is 1 over. Both are same. Yes, this is my differential. This is the integrating factor. If I multiply this by here, it's a y over. I can check about this. Okay, chalo, fine. This is my here, and n is my minus x over x square plus y square. So what is the partial derivative of m with respect to y? I can apply the u over v. So it's a x square plus y square minus y into 2y. So that is x square minus y square over whole square. What is the partial derivative of n with respect to x square? This is my minus x square minus y square and minus minus plus x of 2x. So it will be x square minus y square over whole square. So both are same. Yes, this is the integrating factor, and this is the remaining one is not the integrating factor. You can check also, instead of this I can check also what is my m for this case. If I multiply this by x over y, so x, this is my here, n will be minus x square over y. What is the partial derivative of m with respect to y? 0. Partial derivative of this will be, and you can see both are not same. So yes, this is not the integrating factor. So right answer is my only D is the correct answer. Okay, if the integrating factor of this is my x raised to power m, y raised to power n, fine. So if I multiply this my m, x raised to power 7 y square plus 3y, and n will be x raised to power m of 3 x raised to power 8 my this, then the value of the m and n. So what is that? I can is a x raised to power 7 is common, is a y raised to power 2 plus n. What is the derivative of this? 2 plus n, y of 1 plus n, plus 3 times, it will be y of 1 plus n. So 3 times of this case. Fine. Now for this one, n with respect to y, so I can take y raised to power n is outside. 3y, it's a x raised to power 8 plus m. So 8 plus m of 7 plus m, it will be 1 plus m x raised to power m. Now both are same, so I can equate the coefficients. You can see x raised to power m, and this is y raised to power 1 plus m, and it is x raised to power n, and you can see x raised to power m and y raised to power n. So I can equate both of these. It is 3 of 1 plus n, it must be equal to minus of 1 plus m. I can check this pair. M is equal to n, so it will be 3 into 2 is minus 2, not satisfied. Mn and both are 0. If both are 0, the left hand side is 3, right hand side is minus 1, not satisfied. M is equal to 1, right hand side is minus of 2, is a minus of 6, minus 18, again not satisfied. M is equal to minus 7, it is my plus 6, n is my 2, 1 plus 1, 2, A is my correct answer of this problem. Look at this another one. The equation is my exact for which pair? So this is the m dx, this is the n dy. What is the my? Alpha x 3y square plus cos x, n of x 2xy square plus beta times of sine derivative will be my cos x. Now when it will be exact, if you equate the coefficient, beta is my 1 and 3 alpha is my 2. So what is that? 3 alpha is my 2, alpha is my 2 by 3, beta is my 1. This is the right answer of this problem. Okay, now if this is my equation, then of this, again I can firstly write in the standard form. This is m dx minus x dy. There are so many methods to solve this. The first method is here. I will tell you the one more method. So what is the my? 1 n x minus 1. They are not exact, so I have to find the integrating factor. Clearly say if I subtract them and divide it by n, so it means if I start from here, because I divided by n, so I have written here, it is 2 over minus x. Fine. So what is the integrating factor? So integrating factor is my e of integration of this. So what is that? It is a 1 over x square. Fine. So I can multiply this integration by x square. So it is a 1 plus y over x square into dx minus 1 over x into dy. So what is my solution? So solution is keeping y constant of this portion into dx plus there is no term which involves only y, so that's my 0. So what is the integration of this? Is x minus y over x is my constant. Now y of 1 is my 2. So can you find the value of c? So c will be my 1 minus 2 over 1. It's a minus 1. So my solution will be x minus of minus 1. Now your target is to find the at x is equal to 2. So 2 minus y over 2 is my minus 1. So 3 is equal to y over 2. 6 is my required answer of this problem. This is the first method. You can solve it in this way. What is the second method is? Because I already prefer, whenever you have find the equation of m dx and dy, always prefer this method. Anyhow, second method is you can find the dy over dx from this equation. So it will be x plus y over x. Fine. So you can see it is a linear in y. Fine. So my integrating factor is e raised to power 1 p dx. P is my 1 over x. So this is e raised to power minus log x, that is 1 over x. So my solution will be y into integrating factor, integration of right hand side into integrating factor plus c. So what is that? It's a x plus c. Fine. Now y of 1 is my 2. So can you find the value of c? So c will be my 2 over 1 minus 1, that is a 1. So my equation will be y is x times x plus 1. Fine. Now you can see what is the y of 2. 2 into 2 plus 1, again you can get as 6 is the right answer. Okay, look at this one. If this is the integrating factor for which pair? So what is my m? I can multiply this by x cube into y square. 6y square plus 8xy. N will be my x cube y square, 6xy plus bx square. Now partial derivative with respect to y. So x cube is my outside. It is my 6 y raised to power 4. So 24 y cube is a x y cube. So 3axy square. Similarly for here, y square is my outside, 6x raised to power 4, 24 x cube y plus x cube, that is a bx raised to power 5. So 5bx raised to power 4. Now when they are exact, you can open this. This is the x cube into y cube, x cube into y cube. 24 is fine. x4 y square, x4 y square, that means 3 of a must be equal to 5 of b. 3 of a is equal to 5b. Not correct, not correct, not correct. A is the right answer of this problem. Now again come back on the IIT Jam questions. One of the point which lies on this solution is my here. Clearly say again, this is my m dx plus n dy. Fine. So check what is the my. This is my 1 n x. This is the exact solution. Fine. So once you know it's the exact solution, exact differential equation, the solution will be keeping y constant of y minus x into dx plus there is any term which involve only y. Yes, there is only y of this. So what is the answer of this? Integration of y keeping y as a constant. xy x square over 2 y square over 2 is equal to c. Now what is that? Y of 0 is my 1. Y of 0 is my 1. Can you find the value of c? X is my 0. X is my 0. So c will be my half. So solution will be here. Fine. Now what they want, which of the following will satisfy? Now you can check. Firstly I can take 1 comma minus 2. Is it satisfied? Minus 2 minus half plus 4 over 2, 2. Is it equal to half? It is not. Minus half, but it's a plus half. It's a cancel out. 2 comma minus 1 on this equation. 2 comma minus 1, it's a minus of 2. It's a 4 over 2 is a 2. It's a minus 1 square is plus 1. So again you can see they are not satisfied. So this option is also cancelled. 2 comma 1 is a 2. 2 1 is 1, which is satisfied. This is the right answer. Minus 1 comma 2, so it is my minus of 2 minus of half plus of half, plus 4 over 2 is equal to half. So this will be cancelled out, but minus half and plus half, so the right answer is C is my correct answer. Now again it's a jam 2017. Why is the solution of this? Again you can see this is my m, this is my n. I will check firstly the exactness. So it is my x plus 1, n with respect to x, 1 minus of this. So they are not exact. So I have to subtract them. So clearly say if I divide it by m, it involves both the terms. So I have to divided by x n. So what will happen? It's a x plus e raised to power minus x, and what is the n is? Again same. So the answer is 1, which is a function of x. So what is my integrating factor? Integrating factor is e raised to power 1 dx. Fine. So now I can multiply this term with, so the solution will be y keeping constant of this into here. So x y e raised to power x plus y e raised to power x plus of 1 into dx plus any term which involve, if I multiply this term by here, it will be this. Fine. So there is a 1 of dy is equal to c. So now y is a constant which is outside. What is the integration of x e raised to power x? We all know this is the x minus 1 e raised to power x. E raised to power x y plus x plus y is equal to c. Fine. Now y of 0 is my 1. So what is the value of the c? What is the value of the c? Y of 0, x is 0. So what is that? X is 0 is a minus 1 e raised to power 1 plus e raised to power 0. E raised to power 0 is 1. It's a minus 1. So it's basically a minus 1. This is my plus 1. This is my 0. This is my plus 1 is my c. So c will be my 1. Fine. So now your target is to find the value of minus 1. So what is that? It's a minus 2y e raised to power minus 1 y e raised to power minus 1 minus 1 plus y is equal to plus 1. So what is the value of this? I can see both values is minus this. This is my 2. So y is a common. 1 minus 1 over e is my 2. So what is that? 2e over e minus 1 is the right answer of this problem. You can also see there is one more method. I have used the exactness. You can also check the other method. The second method will be, I can found dy over dx from here. So I can take this on the left hand side, right hand side. So it will be xy plus e raised to power minus x with a negative sign divided by x plus e raised to power minus x. So you can see I can write this is y x plus 1 e raised to power minus x e raised to power minus x over here. So because of outside the negative, I can change this as a negative. Now you can see this is my linear in y. So the integrating factor is e raised to power p dx. So this is my p. Fine. So that will take a lot of the calculation, but once you are using the exact differential equation, that is much easier for you. Okay, look at this another one. It's a 2022 question. 5 of this is there. Okay, which of the following statements are my true? You can check about that. Okay, one initial condition is given to you. You can check it firstly off from the option. What is the value at x is equal to 1? Because phi of 1 is 1. So what is that? Is my 1? 3 into 1 square plus 1, is it 4 into 1? 3 plus 1, 4, satisfied. Is a 3. Phi of 1 is 1. So at x is equal to 1 is a 3 minus 1. Sorry, it's not. It's a whole square. So 4 square is 16, which is not equal to 4. First option is directly cancel out. 3 minus 1 square is my 4. It is satisfied. This value 3 into phi of 1 is my 1 plus 1 of square is 4. Phi of 1 is my 1. So 4 square is 16. Again this option is cancelled. From this case 3 into 1 minus 1 is my 4. So this is satisfied. So B or D may be one of the right answer of this. So I can discard A and C. Okay, now check about the exactness. 2y n of x is minus 4y, so which is not exact. So I can use this. I can divide it by here. So this means ny minus over n. So if I subtract them, it's a 6y divided by minus of 4xy. It is minus 3 over 2x. What is the integrating factor? Integrating factor is e raised to power integration of this term. That means x raised to power 3 over 2. So what is my solution? Keeping y as a constant, I can multiply this quantity with this here. So it will be x of 1 over 2 plus y square x of minus 3 over 2 into dx, plus if I multiply x raised to power minus 3 by 2 here, but there is no term which involves only y, so this is my constant. So what is the integration of this is x raised to power 3 over 2 and it's a 2 over 3. Y square is my outside, it is x raised to power minus half to minus half. I got one more method come in mind directly. Okay, so it will be 2 over 3 x of 3 by 2 minus 2y square over root of x. This is my C. So clearly says that I think there is no need to solve much more. You can see it's a 2x square minus 2y square over 3 is C. Fine. C of root x. I can multiply by root x. So clearly says if I put up as a scaling, it will be x, but here you can see is a y. Phi of x is my y, so this option will be cancelled. You can find the value of c by using this condition, where y is my phi of x. So y is my 1, x is my 1, so this value will be cancelled. Fine. There is one more method coming in my mind. What is that? You can find from this differential equation, you can find dy over dx. What is that? It will be x square plus y square divided by 4xy. Fine? Yes. Now you can see what is that? This is a homogeneous. Fine? Or you can find the integrating factor also by using 1 over nx, because they are the homogeneous. So once they are here, you can substitute y is equal to vx. So it will be v plus x of this. It will be 1 plus v square over 4v. So what is that? X dv over dx. 4v is the LCM. 1 minus 3v square. So what is that? It's a 4v over 1 minus 3v square into dv, which is equal to dx over x. Now that's over. I can make them as a 6v. So 4 I can multiply by 4. I can multiply 6 and divide it by 6. Minus is also. So what is that? It's a minus 4 over 6 log of this quantity, and this is a log of cx. Again you can see the x appears. So x appear means the right hand side must be of the x side. So the right answer is only C. B is my correct answer. Okay, look at this one. So clearly say this is my linear. Fine. What is the integrating factor? E raised to power 3x square of dx, that is x cube. So remember that the coefficient of this must be 1. So y into integrating factor right hand side into x cube. Fine. So what is that? I can multiply by 3 and divide it by 3. So y e raised to power x cube, which is equal to, this will be my e raised to power x cube over 3. So can I find the value of y from here? C e raised to power minus x cube. Now since they are talking about the limit of this, what is the limit as x approaches infinity? So clearly say this term will goes to the 0 because c is my constant. Fine. So c is my constant, this term will be 0. So the remaining part is only here. Or you may find the value of c from here, but there is no need of this. So the right answer is, so you can round off them to the 2 decimal places. 0.33 is my right answer of this problem. Okay, look at this another one. Firstly, you can make the coefficient of the y dash to be a 1. So y dash plus y over x, which is sin x over x into y square. What is that? This is a Bernoulli equation. Fine. So you can find the integrating factor as 1 minus n into p. What is the n is? Sorry, it's a minus of 2 because I have divided by n. Okay, so n is my minus 2. So this is my 3 into 1 over x. So what is the answer of this? It's a 3 log x. So that is x cube. Fine. So what is the solution of this is y into integrating factor, which is right hand side sin x over x into x cube. Fine. Now what is that? This is the, sorry, this is x into x square. So x square, so it is x only. What is the integration of the x sin x? That's again a simple. So that is a x minus cos x and minus cos x minus plus of this. Fine. Now what is the remaining side? You need to find the value of the c. What is the value of y? Pi over 2 is my 0. What is the value of the c? This is my y is 0, so this value will be 0. Cos pi by 2 is my 0. Sin pi by 2 is my plus 1, so c will be my minus 1. So what is the value of 5 pi over 2? So you can see what is the cos 5 pi over 2. So I can say 4 pi here, which is nothing but cos pi by 2, again 0. Sin pi by 2 is my plus 1. So this value will be my 0. This is my plus 1. C is my minus 1. So what is the answer of this? Y into 5 pi by 2 square is 1 minus 1, 0. So y must be 0. So the right hand side is 0 is the right answer of this problem. Fine. You may think about this equation as a first differential equation as well. But I can quickly say this is the Bernoulli equation. You can solve it in a simple manner. I hope you can learn these various tricks. We will see the next lecture on the first order differential equation, how you can find the solution which are not solvable by the exact differential equation of these papers. I hope you can like, share and comment on my video. Best of luck students. Happy learning always.